All right, now we're going to look at the area of a rhombus. It says fill in all values and find the area of the rhombus. Our area formula for a rhombus is the same as a kite. It's 1/2 times your diagonals, diagonal 1 times diagonal 2. So if we can find our two diagonals, we can find the area. Well, one of the diagonals is this 24. So we've got that one. The other diagonal, we do not know what that diagonal is. So let's just think about what we know about a rhombus to see if we can find the values or how long that diagonal is. Well, one fact we know about a rhombus is that the diagonals bisect each other. So if our diagonal 1 was 24, that makes each side 12. The other thing we know about the diagonals of a rhombus is that they form right angles. So similar to the last example, and just a lot of these will be kind of similar, we've got a nice right triangle. You guys are experts at right triangles at this point. They are so common. We know this is 12, this is 13, and we have our missing side. So can you use Pythagorean Theorem? Of course you can. 12 squared plus x squared equals 13 squared. Can you see if it's a triple? Of course you can. Well, 12 and 13 don't reduce, so is there a triple that uses 12 and 13 with 13 as the hypotenuse? And for those of you that know your triples, you say, well, yeah, there is. It's a 5, 12, 13 triple. Our missing side is 5, so you can get the 5 with your Pythagorean theorem, or you can become familiar with your triples. I lean toward triples because it's less work. And even though I love math, and I really do, I still like to do the problems as efficiently as possible. All right, so that means that this is a 5, and because the diagonals bisect each other, this is a 5 also, meaning that our full diagonal is 10. Now we have enough information to find our area. It's going to be 1/2 times 24 times 10. Oops. So half of 24 is 12. 12 times 10 is 120. And then we need our own unit. So we're going to say units squared because it's an area measurement. So our second example with the rhombus area tells us that the area of a rhombus is 24 inches squared. So instead of trying to find the area, they actually gave us the area first. This means we're going to set up an equation and solve for a missing piece depending on what they're asking for. They also told us that the length of the longer diagonal is 8 inches. Find the length of the shorter diagonal. So if we look at the rhombus in the picture, the longer diagonal from here to here, that is 24. And we need to find the shorter diagonal from here to here. Well, because they gave us the area, we're going to use the area formula. Area formula for a rhombus is 1/2 times one diagonal times the other diagonal. The area is 24, so we're just going to plug that in. 24 equals 1/2 times. Now, it doesn't matter which diagonal you plug in here. You know that we know one of the diagonals is, oh, did you guys catch? I wrote 24 over here. What was I thinking? That's an 8. Sorry about that. One of the diagonals is 8. It doesn't matter if you plug that in for D1 or D2. So I'm just going to put it here first, and then we're going to solve for D2. So when we're solving this equation, we can go ahead and multiply 1/2 times 8. We can do that simplification. We can simplify that. Half of 8 is 4 times D2. Now this 2 with the D, it's not a number that's part of our equation to solve. It's just part of the label. It's a subscript. It tells us it's the second diagonal. So we're solving for D2. Don't think you have to get the 2 to the other side because it's not a numeric value in our equation. All right, to solve this, we notice that there is multiplication between 4 and our diagonal. So we will go ahead and divide both sides by 4. leaving us with finding the diagonal to be 6. 24 divided by 4. So now we look to see what kind of label. I can see everything is in inches. So it's 6 inches, and so the question is, should we put inches squared or just inches? This is not an area measurement, so we are going to leave it as 6 inches.